Hello, this is Jim McKeeth, and welcome to this CodeRage 9 session on voice enabling your Android apps. What we're going to cover is we're going to start with voice launching Google Glass apps with both standard and unlisted triggers, and then we're going to also look at additional prompts on Google Glass where your app can start with some input. We'll look at voice recognition on Android as well as Android Wear, and also text-to-speech on Android. If you caught my skill sprint on this topic, we're going to have some overlap. We're also going to take a little bit further as we're going to look at using voice recognition for navigation as well. So to start with, voice launching Google Glass apps, you have to add a voice trigger XML file, and there's a list of standard voice commands you can see there, and you want to deploy this XML file to the res XML folder. So you do this through the deployment manager, and in your XML file, then you're going to modify your Android manifest to add an intent filter to say that your app takes a voice trigger. And then you specify metadata pointing to your voice trigger file. So if your voice trigger file is called myvoicetrigger.xml, then you will say Android resource equals at xml/myvoicetrigger without the .xml. Okay? So if you're doing a custom glass voice trigger, you need to also add a permission for development. So custom glass voice triggers are only for use in in-house or ad hoc deployment. You can't deploy these through the Google Glass App Store distribution. So this allows you to use any arbitrary text for voice triggers instead of the preset list that Google provides. Now, if you have a good reason that you want to use this particular trigger, you can actually submit it to Google and they can add it to the list. And what that does allows them to do some pre-modeling ahead of time to make sure it works well offline. Now, if you want to do an additional prompt for additional input, you can do that as well by adding an input prompt to the voice trigger. So the default voice trigger is to just say trigger command equals and then whatever it's going to be. So the default one for taking a note is take_a note. So that's what you'd use to take a note. Now, if you want to do a custom one, you could modify that to anything, and I'll show you an example of that. But if you want to do an additional prompt, that's where we see here where it says input prompt equals what shall I say? And what that's going to do is after the user says, okay, Glass, take a note, it's going to then pop up and say, what shall I say? And this gives the user an opportunity to provide some dictation for input that comes to your app. And so this happens before your app is launched. It's capturing this additional input and passes it to your app. So this way you don't have to actually implement voice recognition in your app if you don't want to, because all this is done ahead of time and passed to your app. And then in your app, you get the extras from your intent, like you see there, in order to get the text that's added to it. All right, so now for additional voice recognition on Android, you can actually prompt the user for voice input, and this is going to return up to 5 guesses. Now, it's guesses because it's doing its best to guess what it is you're saying. It actually works offline as well and only returns 1 guess in that case. And what I've done is I've created a reusable component, which I'll tell you a little bit about in a second. So that you see there, this is the prompt that comes up to prompt you for input on your Android tablet or Android phone. So you need to have the record audio and internet permissions. So record audio is obvious because it's opening the microphone to record the audio of your voice. But that recording is then taken and sent to Google servers. And then the server processes that audio, uses the context of your sentence to select what words best make sense. So for example, if you say, I read a book, then read probably means read as in past tense of read a book, not red as the color. So that's some of the ways it is able to decipher that. Also, if you want to add punctuation, you have to pronounce that. So you'd say period at the end of a sentence, or comma, exclamation mark, question mark, etc. So the voice recognition works on Android phones and tablets, also works on Google Glass and Android Wear. It doesn't work on iOS. Now, the component right now is only implemented for Android, but iOS doesn't provide a voice recognition API. There's a third-party one, politepix.com/openears. This is seems to be the recommended one. So it's conceivable we could implement a component that talked to this API that then would work possibly across platforms. So that's not something I haven't implemented yet, but who knows? Stay tuned. Maybe I or somebody else will implement that in the future. So I've created a T speech recognition component. It has three properties. Language, which defaults to EN-US for English US. I've heard reports this works with other languages, but other people have used it. I believe you have to have those languages installed on your phone to be able to do that. So experiment with that as you see fit. You can also specify a prompt. The prompt is what's going to appear on the little dialog that says that's prompting the user for input. So you can tell them what you want them to say or what kind of information you're looking for. And then always guesses is one feature I just added. And this comes down to the ability that I've given it the option to listen for specific things. So what that means is the method you can call listen, and this will just return 1 to 5 guesses, however many guesses it guesses for what it was you said. But you can also say listen for, and listen for you can pass an array of inputs you would like to hear. So these could be words or phrases or whatever that you're looking for. And then it will then tell you which one of those phrases it got back. Okay, so now if you say always guesses is true, then on recognition and on recognition EX will always fire. So on recognition is going to be the default, the first guess, the best guess. On recognition EX will give you up to 5 guesses. My experience has been if you're online, you always get 5. If you're offline, you only get 1. And then on command is going to return which of the listen for possibilities that you provided was the one that was heard. So if always guesses is true, then on recognition EX fire even when you say listen for. If always guesses is false, then listen for only results in on command being fired. If none of the items in your list is fired, on command fires with no value coming through to it. Okay, so now let's talk about text to speech on Android. This converts your text to spoken word. This is actually based on, is actually a reusable component I created based on Jeff Overcast's translations. He did most of the hard work. I just wrapped it into a nice, easy to use component. If you look in the code, though, it shows an example of handling Java listener events, which could be useful in other places when you're wanting to respond to Java listeners. So this text to speech works on Android phones and tablets as well as Google Glass. It doesn't work on Android Wear, and the reason is Android Wear doesn't have a speaker, so you can't have it talking to you. It'd be nice if it did, but unfortunately it doesn't. iOS support is possible, but it's not implemented. And again, these components are just for Android, but this same sort of functionality is possible on iOS. So using the Android TTS component, you drop the component down, and in your code, you just call speak and pass in a string of what you want it to say, and it will say that string. It does a pretty good job, and it sounds pretty good. So a note about iOS, both voice recognition and text-to-speech. iOS does not expose voice recognition APIs. Like I said, there is third-party ones available, so it's possible you could wrap that and call that, but it hasn't been done yet that I know of. I haven't done it. iOS 7 does add support for a text-to-speech API. I believe it was iOS 7 that was introduced in. It's called AV Speech Synthesizer, so could easily wrap that up into a component as well to be able to do text-to-speech on iOS. So could be done. I just haven't done it yet. Maybe in the future I or somebody else will. Stay tuned. Okay, now let's do a demonstration on voice recognition and text-to-speech across a few different Android devices.
So let's look at making a Glass voice trigger app. So we have a Google Glass app we've created, and we want to make it launch via voice trigger. So first thing we do is we have to modify our Android manifest. Now there's 2 required modifications and 1 optional modification. The optional modification is we can say uses permission development. And so this is what we need to do for unlisted voice commands or non-standard voice triggers. So if you're not wanting to use a trigger that's on the approved list by Google, either A, because you're waiting for your trigger keyword to be approved, or B, you're not planning to distribute it through the Google Glass store, you only want to distribute it in-house or ad hoc, then you can use this permission. So it can only be installed on devices that have development turned on. So then the 2 required ones are down here in our intent filter section, so activity intent filter. We add this line here that says that we have an intent filter for a voice trigger. So that means our app can be launched by a voice trigger. And then we specify some metadata outside the intent filter. Here we say metadata for the voice trigger. We specify the XML file that we use to trigger our app. Okay, so at XML/ and then voice trigger is the path to the XML file that we want to use, or the name of the XML file we want to use. So here is our XML file, and it has a .xml at the end. So this leaves the .xml off. And so then we create our XML file. So our XML file can take a few different forms. This is the common form. We're using a stock command. So in this case, we're using the take a note command. So take a note, this is a constant that references the take a note key phrase that is defined by Google. And then here we're also asking for an input prompt of what shall I say. Okay, so the alternative is if we're using a non-standard one, we would replace the word keyword, or replace the word command with keyword, and then this could be any arbitrary text we want it to be. So if we wanted to say count to 1,000, we could say that. You know, whatever you want to put in there, you could do at that point if you use keyword. And again, that requires the development permission. And then this line here is optional, where you have the input prompt. So the input prompt prompts the user for additional input that is then passed into your application. So once that is passed to our application, here is how we get that out. We go in here to the code, and we go to the form show event. And what we do is we need to get the intent that is passed to our application when it's launched. And so intent is an object that is sent to your application that tells your application to launch and can have extra information in it. So we go into the intent, and we get the extras called extra results. And we then spin through that list, and we add that to our list box. So our list box is going to contain a list of all of the strings that are sent to our application. And then we're also, just for amusement purposes, we're going to speak whatever was just told to us and then listen again using the text-to-speech and speech recognition components, which I'll show you in a few minutes. Okay, so let's go ahead and take a look at this app running on Google Glass. Okay, Glass, take a note. Glass voice trigger. So this is the part where I am prompted to provide additional input via my voice. So you notice it did okay there. It didn't get exactly what I said, but I kind of mumbled at one point. So we didn't actually see the text displayed on the screen, but it was displayed, and then hopefully you heard it using the text-to-speech. And we're doing it again. And again, we didn't see it, but it was coming out via text-to-speech. So I guess I should put a delay in there so that it shows you the text before prompting you for more input. So this is what I call the annoying 2-year-old or 5-year-old or whatever age it is at which kids decide to repeat everything you say, and you say, "Stop repeating me!" And they just say, "Stop repeating me!" And it goes on indefinitely until one of you gets annoyed and stops. Anyway, that's enough of that. So I swipe down to go back, and you can see here's the text displayed now. It's only displayed in one row. I should probably put this in a memo box instead of a list box so that you can actually see the full text with word wrap. But anyway, the code's the important thing. You saw the code for how to get the text that's passed to you through an additional prompt on Google Glass. So this is the Pascal version of my demo that is in the project for shows off both the speech recognition and the text-to-speech. So here's the speech recognition component. I don't have an icon for it yet. And we can see the properties here. We have a language, which right now defaults to EN/US. Like I said, this should work with other languages. I just haven't tried it because I don't have them installed on my phone. And then the prompt is speak now. You can change this prompt to whatever you want. Like that. And then the events, we have the on command, which I'll show you in the command sample, which is for listening for specific commands. And then recognition and recognition EX. So recognition is going to give you a single guess. So the result is going to give you one guess that comes back. The recognition EX gives you a string array of up to 5 guesses. Okay. My experience is usually it's either 5 or just the 1. Although occasionally you'll see times where it's just like 1 or 2. Or it gives you less than 5.
So what this sample does is it just puts the whatever it was this user says into this list box here, and then you can double tap an item in the list, or sorry, list view, and then you can double tap one of the items list view to say it again. You have the option of typing, which will bring up the little edit box here where the user can type in what they want it to say, and it will do it. Now this is actually really impressive if you're online. So let me go ahead and show you a demo of this really quick, running on my Nexus 5.
Double tap to repeat a line.
So here's the application running. I'm going to go ahead and do listen. Hello, my name is Jim McKeeth.
Hello, my name is Jim McKeeth.
So we see this time it got 2 guesses. It did pretty good on this. The second one is apostrophe possessive on my name, plural. I'm not sure why. The value of pi is 3.14.
The value of pi is 3.14.
So again, did pretty good for a number on that one. So I'm going to go ahead and turn off my Wi-Fi, so we're offline. And now we'll do this. Can you hear what I am saying now? Question mark.
Can you hear what I'm saying now?
That did really good, even being offline. But you notice this time I only got 1. So if I'd done this online, it would have gotten more possibilities back probably on that one. Let's go ahead and do another one. My voice is my passport. Verify me.
My voice is my passport. Verify me.
Again, only 1. So let's go ahead and go back online. Take a second. Okay, I'm back online again. So now we'll listen. This is a full sentence, comma, or at least I think it is, period.
This is a full sentence, or at least I think it is.
All right, so we see this time we got all 5 back because we were online. And we see there's some subtle changes, variations between those. Again, it does really good recognition. Embarcadero Rad Studio XE7 is a great development tool for mobile applications, period.
Embarcadero Rad Studio XE7 is a great development tool for mobile applications.
There you go. Can't hardly argue with that. I'll go ahead and do the type. This is what I am typing. If I can type P-I-N-G, typing, period.
This is what I am typing.
And so it says it back. You could obviously type gibberish. And it does its best to try and understand what you're typing there. Now, my speech recognition demo, you'll notice I also have this Android Wear views, and what this does is it adds views in for Android Wear, which I've already installed in my IDE, so I can actually run this on my Gear Live. So I select Gear Live from my drop-down list here, and run it, and we'll see it running on my Gear Live. So I'm using this screen mirror program to show the screen on the Gear Live. So I'm going to go ahead and tap the listen button. This is my watch listening to what I say, period. So you see this is was able to voice recognize me. One note is that the watch doesn't actually have internet access. It does this through the phone. So the voice recognition, you have to be connected paired to your phone, otherwise the voice recognition won't work. Just delete some of these lines here. Embarcadero Rad Studio XE7 is the best tool for Android Wear development. So we see it did pretty good. I got Embarcadero Rad Studio XE7, but Android Wear, it said where instead of where, interestingly. So anyway, there you go. We see it working on the Android Wear. Now you notice that it's not doing the text-to-speech. It's making the call to text-to-speech, but there's no speaker on the watch, so there's no sound coming out, so text-to-speech does not have any effect. But the voice recognition does work just like you would expect it to. Okay, so this is the Pascal version of my voice command example. So again, we're using the speech recognizer component. The difference is this time I have the on command event handler on here, and I have the always guesses set to true. So we're also getting the on recognition EX event. We're going to hand that. So what we're going to do here is we have actually a menu that we can navigate through. So if we look in here in the code, here's the different menu options. The top menu, you can reset, change the color, or go to full screen. And then when you're in the color menu, you can choose from those colors. Full screen, you can say full or restore. And in reset, you can prompt verify that for yes or no. So there's a little state machine that handles the different states there and applies the effects. Really simple, crude example here just to show you how you would do this. So let's go ahead and run this on my Nexus 5 and take a look at it in action. So here it is running. When I tap the list button, it will display the menu for me. Color. So we see here the one with the arrows next to it is the command that it got, and then the next one is the different 5 options. And so it got color and all these different things. But since we found one that's color, it has that command. And so we know that that command is fired. And so now when I tap listen, we're in a new state. Red. And so we see it recognized the red command, and we changed the button to red. And now we're back at the top menu. Color. And I can do it again. Blue. And we change the button to blue. Reset. Yes. And we see we've changed the button back. And I can do the same thing. Full screen. So now we're at the full screen menu, which is going to prompt me for verification. Full. And now our app's gone into full screen mode. Reset. Yes. And we're back out of full screen mode. Very simple example of using voice commands to navigate through your app. So this could actually automatically, when it finishes, when the event fires, it could prompt again automatically, could automatically display that, and we could change the prompt in the voice recognition dialog to perhaps show what the options are. So all those are possibilities that you can use in building a voice recognition application. Okay, so summary, we looked at how to use voice to launch Google Glass apps. We also looked at additional voice prompts in Google Glass with voice input, and voice recognition on Android in general, and text-to-speech on Android. For more information, you can check out the Google Glass sample. There's the path to there. It's installed with your XE7 installation. And also check out the doc wiki for documentation on that example. The documentation only covers the Delphi version of the sample, but there is both a Delphi and a C++ version of that sample. You can get a list of the Google Glass supported commands there, the Glass voice triggers. And then I have 2 blog posts. The first one is my original blog post from when I did the skill sprint. The second one is this blog post specific to this CodeRage session that's going to go cover the commands as well, the command recognition. And now if you're here for the live CodeRage session, we're going to do live Q&A. So there's a few questions here on the Android voice enabling your app. It says, why is this Android specific? I thought if I wrote code once, I could compile it on iOS and Android. So you can compile all your code on iOS or Android, but the limitation is that if you're calling an API that's specific to one platform or another, then your code would become specific to that platform. And so at that point, you can use compiler directives. Now, everything I'm showing you here is Android-specific APIs. iOS does not have a voice recognition API built into the OS. So there is not an iOS equivalent of that. iOS does have a text-to-speech API, though, that came out in one of the recent versions of iOS. I'm not sure exactly which version it was, but it was fairly recently. And so you could wrap that API on iOS and the API on Android, and then have one component that could call both those APIs depending if you're on iOS or Android. And actually Windows and OS X also have a text-to-speech API. So You could write a component that could work across all 4 platforms for text-to-speech, and you could write your application once and compile it and run everywhere. But for voice recognition, the only place that has one built into the OS that I'm aware of is Android. The OpenEars PolitePix is a library that's available for iOS by a third party to do text or voice recognition. They only provide iOS binaries. So they actually give you binaries that you would include in your application in order to use their service and do the voice recognition. Since they don't provide an Android version, you would either have to rewrite that on Android or create a facade so that you're able to call either API, the Android API or the PolitePix OpenEars API on iOS in order to do voice recognition across platforms. So, yeah, OpenEars PolitePix that I mentioned is only available for iOS. They do not have Android support as of this time. So the question is, can you create an app where you can tell it to use the camera and then take a picture on command? Yes, you could do that. The code I'm showing you, you would have to tell it to keep listening. So you'd keep, if it doesn't hear something, listen again, etc., until it hears the command to take a photo, launch the camera, or whatever it is you decide to have it do. If I remember correctly, there is an Android API to have it keep listening without having to keep launching the listen event. Just look into the API headers that are included in that download as well. Is there something like this for Win apps? Yes, Windows and OS X have voice or text-to-speech, as does iOS, I mentioned earlier. I think Windows does have a voice recognition API as well, but I'm not positive. I haven't seen any examples using that. I know that they have that feature built into OS, as does the other OSs, but I'm not sure if it's exposed as an API. It probably is on Windows. If I remember correctly, there was a CodeRage a few years ago that showed examples of at least doing text-to-speech on Windows from Delphi. So you can go back and check that CodeRage out, find out how to do text-to-speech. And actually it was pointed out that Chant, which is at chant.net, has a speech kit library for Delphi that you can use to do speech-based solutions on Windows. So check that out from chant.net/product/speech-kit for speech recognition. Yeah, speech recognition on Windows. So there you go. Right there. That's a great solution for Windows. Here's a question about deployment requirements. Are there any additional libraries? So for what I'm showing you on Android, because this is baked into the Android OS, all you have to do is use these units, these components that I've provided here in your Android applications, and you'll be able to develop your apps without any special deployment requirements. Now, it does require that your app has record audio and internet permissions, which I know we have internet on by default in a new project, but I'm not sure about record audio. So go into your uses permissions in the project manager and make sure you have record audio and internet turned on. Run the sample application, look at the permissions on there, drop those components on your form. If it doesn't work, check out the permissions, see what permissions are different. You'll be able to figure it out pretty quickly. I believe those are the two you have to have, is internet and record audio permissions. Anyway, that's all we have for this session on voice enabling your Android applications. Thanks for joining us.